Very good morning to all. I'm going to take object-oriented analysis and design, the first unit. The reference book is Ali Brahmi, author Ali Brahmi, written by, the name of the textbook is Object-Oriented Systems Design. Okay. So object-oriented analysis and design is an important subject. You might be knowing that the prerequisite for the object-oriented analysis design is software engineering and object-oriented programming. Okay, so having the confidence that you have a thorough knowledge on software engineering and various phases of software engineering, then object-oriented programming, the language, we are further proceeding to object-oriented analysis and design. Okay, so let us see the orthogonal views of the software. There are two approaches, the software development approaches. One is traditional approach and another one is object-oriented approach. Traditional approach is the one which we are very familiar. The object-oriented approach we are going to study now. Traditional approach, it's a collection of programs or functions where the functions will be the sinusoid, the center of the focus, and the system that is designed for performing certain actions, where we will have the algorithm and the data structure, predominantly using algorithm data structure to write the program. And we have the well-defined software development models like waterfall model, spiral model, incremental model. You would have studied all these software development models in the as part of your software engineering subject. Okay, so if you take any software engineering organization, industry, software development organization, they will use either any one of the software development model. Either it may be software waterfall model, spiral model, or incremental model. Okay. So it's a time to know the difference between traditional versus object-oriented approach. Okay. Where in the traditional approach we have the collection of procedures or functions. Here in object-oriented system development, we have combination of data and functionality. We have it most important for the objects. So object consists of data and its functionality. So the traditional approach focuses on function and procedures, different styles and methodology for each step of the process, whereas the object-oriented system development focuses on object classes, modules that can be easily replaced, modified, and used. That is a strength of the object-oriented system. And traditional approach, moving from one phase to another phase, is very complex. We have to complete one phase, then we'll go to the next phase. Then in the object-oriented environment, moving from one phase to another phase is very easy, and it is increase the duration of, if you opt traditional approach, the time taken for completing the project is high, whereas in object-oriented system, it is very low. And the complexity involved in the traditional approaches is high, and so the complexity involved in object-oriented system development is low. So knowing the benefits of object-oriented environment, people are shifting from the traditional approach to object-oriented approach. So when we look at the software development process, see, software development process is a dynamic process and undergoing major changes. Okay, so the thing is, once the requirement is given to the development team, it doesn't mean that that is the final requirement. The client will keep on changing the requirement accordingly. We have to work. So that's what we call the software development process as a dynamic process. It's not a static process, and we need to be ready to work for the varying requirements. System development refers to all activities that go into producing information system solution. The main objective is to develop an information. I have asked this questions in the previous classes. What is a software? Have you developed any softwares? Okay, and I told you I have developed a number of softwares from first year to third year, and you have as part of your laboratory. So the main objective of the software development process is to develop an information system. It provides some information. When you look at this development life cycle, software development life cycle, we have 7 phases. It starts with requirement specification, system analysis, design, coding, implementation, testing, and maintenance. Okay, we are dealing here the second and third, analysis and design. So basically, a software development methodology consists of series of process, and it leads to the development of an application. application for the end user, application for the users, common people like you and me. Okay, it may be a railway reservation system, it may be a library management system, it may be an inventory systems. Okay, basically we are focusing on people. We are satisfying the requirement of the customers through the application. So an interesting diagram. This is what is actually happening in the software development organization. The first diagram we look at, this is what the customer is explained about the project to the developer, and how the project leader understood is this one. And the analyst role, he analyzed in this way and designed it in this way. And the programmer has wrote the programmer in this way, and how the business consultant described this way in a sophisticated manner. And nothing has been documented. So customer explained and the project leader understood, and a designer designed, and the programmer wrote the program, and how the business consultant described it, and how the project was documented, and what operations are installed is depicted in this diagram, and how customers was built in this way, and how it has been supported, and how the customers really, what customer really needed this one. So actually this is what the expectation of the customer. But even the customer, when he communicated to the developer, he himself communicated it in this way. So when you develop a software, as a developer, you will experience the same thing. You cannot expect that the customer will give the right requirement, or customer will reveal the right requirement to the developer. Okay, so you can able to visualize the job of the software developers, or the people working in software development environment. Okay, let us see what is an object. An object is a combination of data and logic. Okay, it consists of, when I say object, it consists of data and the functions. Okay, so an object is a combination of data and logic that represents some real world entity. Real world entity, you would have studied the entity relationship diagram in database management system. Okay, the entity where we call that as the entity. Okay, now object has three aspects. The first object aspect is what it knows. It identifies and certain attributes, what it knows as an object. Okay, a human being has can have the attributes as name, age, qualification, etc. Who it knows, relationships to other objects, how these objects are related with each other, what it does, the functionalities. As a human being, as a person, as a teacher, what I can do now, I am sitting in front of you and teaching you. Okay, so this is my teaching, is my function. Okay, what it does. So three aspects: what it knows, who it knows for collaboration, and what it does on its own. This is what the functions. So the combination of the attributes, the relationship, and the functionalities we will see with respect to the objects, each objects. So understanding and analysis is nothing but in software engineering, analysis is the process of converting the user requirement to system specification. Okay, it's very you must understand that thoroughly. Analysis is nothing but converting the user requirement into system specification. We will get user requirement in the form of natural language, in the form of software requirement specification. That specification will be transformed to system specification. System means the software to be developed. Okay, because the client would convey the requirement in their own language, but we need to convert it into our language. Okay, system specification language. System specification, also known as a logic structure, it is the developer's view of the system. So here the functional orientation is nothing but concentrating on the decomposition of complex functions to simply ones. It is our responsibility to decompose the complex functions to simple ones. And object analysis is nothing but identifying objects and relationship between the object. The entire object-oriented analysis and designs, we are talking about object and identification of object, identification, the attributes, identifying the relationships playing vital role. What is understanding? The goal in analysis is to understand the problem and to begin to develop the visual model of what you are trying to build, independent of implementation and technology concerns. Okay, so we will see what is analysis and design in the future slides. So analysis is nothing but understanding, finding, and describing concepts in the problem domain. We are dealing with the problem domain, understanding the problem, what the problem is, exactly what is the problem. Okay, I have explained in the previous class, building a house. Okay, building a house like Sachin Tendulkar's shell house. Okay. It requires lot of analysis. It requires lot of feasibility study. It requires lot of requirement specifications. Okay, so study on the requirements, whether it is possible, whether it is feasible. Okay, everything is part of the analysis. So having the understanding of the domain, problem domain, and finding, describing the concepts which is there in the problem domain. Design is understanding and defining software solution objects that represent the analysis concepts and will eventually be implemented in code. This should be given to the developer for writing the code. So object-oriented analysis and design is nothing but a software engineering approach that models a system as a group of interacting objects. The object analysis design is a software engineering approach. So here, if you look at this first difference, focuses on understanding the problem. Okay, so that is nothing but analysis. Analysis, we are focusing on the problem and trying to understand the problem. That is what analysis. Design, focus on understanding the solution. What type of solution I can provide? What type of design? When you design, once the design is completed, you will be knowing about what kind of solutions you have identified, chosen for problem. Okay, so idealized design, its operations and attributes are there, behavior, system structure, functional requirements. It's a small model, whereas the analysis, it's a very small model. We are in the analysis, we are dealing with the functional requirement. You would have heard about functional requirement and non-functional requirement. So the requirement of the customers can be divided into functional requirement and non-functional requirement. The functional requirements are the functions directly involved with the system. If you take banking applications, opening an account is a functional requirement, updating information to the database is a functional requirement. Okay, whereas the performance of the system is the non-functional requirement. Okay. So design, operations, and attributes, we have performance. We are dealing with the performance and close to real code, because next step is to coding. And object lifecycle, we are dealing with object. We are dealing here in the design phase, we are dealing with non-functional requirement, and it's a large model. So it is the output of the design phase is the final design. So object-oriented development offers a different model for traditional software based on functional procedures. So here the software is a collection of discrete objects that encapsulate the data as well as the functionalities. When I say an object consists of collection of attributes. Attributes mean its properties and the functions, what it can do. Okay, so the encapsulation of all the data and the functions with respect to a particular object. So software is a collection of discrete objects, okay, where we will have different types of objects, that each object encapsulates its own data and its own functionalities. So each object has attributes. As I mentioned earlier, if I say whatever I can see in the real world, I can assume it's an object. Here I'm sitting in front of a laptop. I can consider this laptop as a object. Okay, and I can consider my mobile phone as an object. Okay, phone has its own name, it has its own model, it has its own specifications. These are all its attributes. What I can do, I can make call and I can see YouTube's videos. I can use it for different functionality. It provides different functionalities. Okay, so everything, whatever you see, you can assume, you can consider it as an object. Whatever you see in the real world, it can be considered as an object, and you can identify the respective properties and the. So similarly, when you get a domain problem, you have to your first job. I'll tell you the steps involved in the in identifying the objects and the relationship. Each object has attributes. Each object has attributes and methods. software by building self-contained modules or objects that can be easily replaced, modified, and reused. That is the strength of object orientation. You can replace, you can modify, and you can reuse once the object which suppose when you develop an application for a banking, the same model can be used for other banks with some modifications. Okay, you can use the same objects and you can make some modification over there. So we can encourage the component-based development or the rapid applications. Objects grouped into classes, and objects are responsible for. Now we will slowly move to what is class. Okay, I'll explain what is class. The objects grouped into class. The collection of the similar objects are called the class. Okay, so or in other words, I can say that the instance of a class is an object. Then benefits of object orientation is faster development. As I mentioned, component-based technology development and rapid development. These are all helping us to for the fast development of the software. So it is need of the hour because once when we apply or when the reusability concept in the software development environment, you can save time, and in the meantime you can complete your project on the stipulated time. Reusability, as I said, it encourages reusability, and so the quality also high when compared with the traditional thing. And modeling the real world and provides with the stronger equivalence of the real world entities. So raising the level of abstraction to the point where application can be implemented the same term as they are described. So why object orientation? Though we have enough justification given for the object oriented, let us see some more important things. Object methods enables to develop set of objects that work together. Okay, finally, we will get a software, and similar to the traditional model, it adopts changing requirements, easier to maintain, more robust, and promote greater design and coding reusability. These are all the major strength of object oriented programming. So when you look at this object oriented, so far I have given an introduction for the object orientation, object oriented environment, object oriented development, object oriented software development. Okay, so we are very familiar with the development methodologies for software development. Okay, the waterfall model, spiral model, prototype model. We have different models, but what is there in the object-oriented approach? Here, let's start with the unified approach. Unified approach is a methodology for software development. What software development? Object-oriented software development. Okay, we need to follow an internationally accepted approach to develop the software development. Underline the word internationally accepted, because developing a software is not for our own usage. We develop a software for various people, multiple views. People from different geological location will be using your product. Okay, so you have to consider the internationally accepted unified model. So the name of the model which is recommended for developing object-oriented software development is unified approach. Okay, don't forget this word, unified approach. Now let's see who developed, who contributed this universal approach. Okay, once this object-oriented approach came to this picture, and people have started proposing various approaches for the development of object-oriented system. Many people, many researchers on with traditional software development approach as a reference, they started giving lot of solutions. So here we have finally the approaches mentioned by Buch, Ramba, and Jacobson have been considered for the software development, object-oriented software development approach. The unified model is called the unified approach. Okay, so the combined effort of Buch, Ramba, and Jacobson gives the best practices, process, and guidelines for object-oriented software development. Okay, so when I ask who has contributed for unified approach, the answer would be Buch, Ramba, Jacobson methodology. They are the pioneer in software engineering. They have given a lot of models for even the traditional approaches. Okay, the combination suggested by, recommended by Booch, Rumba, Jacobson finally have been considered universally accepted as a unified approach. Okay, so it combines with the object management groups in unified modeling language. So unified approach utilizes the unified modeling language. So throughout this study of this objective analysis design, we are going to see a lot of programs um, of unified, a lot of diagrams of unified modeling language. Don't be confused with the word language. It is not a programming language. It's a design language. Okay, it's called unified modeling language, which is a set of notations and conventions used to describe and model an application. So it recommends different types of notations, helping us to design the software, object-oriented software. So layered approach, what kind of architecture is recommended for unified approach is called layered architecture. Unified approach uses layered architecture to develop application. It creates objects that represent elements to the user through interface or physically stored in database. The layered approach consists of 3 layers: user interface, business, access layers. Okay, so we have to divide the entire design into 3: user interface, business, and so that we can draw the architecture, we can design the design the software, proposed software with the help of this layered architecture. If you split it into user interface as a first layer, business as a second layer, and the access layer as this third layer. This approach reduces the interdependence of user interface, database access, and business control. It is more robust and flexible system. So basically, an object, the developer should know the definition for objects. If I ask you now what is object and what is class, can you define a class? Can you define an object? Okay, it is very easy, no? So you have the enough knowledge on the objects and design, object and classes. So it describes objects, methods, attributes, and how objects respond to messages. Okay, so we have to define the polymorphism, inheritance, data abstraction, encapsulation, and protocol. These are all the characteristics of various characteristics of object-oriented programming. Okay, so the prerequisite for this course is software engineering and the object-oriented programming. Okay, where in the object-oriented programming, the first concept we would study is the characteristics of object orientation. So class, objects, polymorphism, inheritance, data abstraction, encapsulation, and protocols. Then we need to know how to describe the object relationship. We need to know how to describe object persistence. So let me give some example for the object-oriented systems. In object-oriented system, everything is, I already mentioned everything as system. Okay, if you're going to develop an automation system for our college, you can consider the college as an object. So further, if you go, you can consider the classroom as an object. If you go to the human people, the staff, you can consider them as an object. Okay, so if you take a spreadsheet, shell, bar chart, title, in bar chart, report, these are all various objects: numbers, arrays, records, fields, files, forms, invoice. Everything can be considered as an object. A window object is responsible for thinking like opening, sizing, and closing itself. Okay, here you can see a window. Okay, so while developing this particular editor, they would have assumed it's an object. Okay, it has various functions. I can open it, I can close it. These are all the various options. The provision must be given for typing and visualizing things. A chart object is responsible thinking like maintaining data and labels, even for drawing itself. Okay. So the term object was first formalized utilizing the similar language to simulate some aspects of reality. Whatever you see in the reality, you can consider. An object is an entity. It knows things. Already we have seen its attributes, or it knows things, and it does things, or the functions. So object attributes represented by data types. Each attributes will be represented. When I say the name as an attribute of the object, name is a string. Okay, we have to define the data type for the particular attributes. They describe the attribute state. So if you take the car example, the color, manufacturer, cost, owner, model are the various attributes of the car. Here, if you look at this is a car, and the car is talking to you that I am a car. I know my color, manufacturer, cost, owner, and model. I know how to stop it, how to drive it. Okay, these are all the various functions. Okay, so if you buy a car and the stopping function is not there, the major functions, drive, stop. Okay, so applying gear. These are all the some of the functions. If you look at an employee, he is saying that I'm an employee. I know my name, social security number, and my address. I know how to compute my payroll. This is what the responsibility of this employee in an organization. Okay, in an organization, and he is he knows how to compute the payroll. Okay, this is one. Similarly, you can identify your own object, and you can identify the attributes and the relevant functionalities. Okay, objects are grouped into classes. Okay, so this is what the relationship between object and the class. So all similar objects are we can put it into cluster it into a class. The role of a class is to define and attributes and methods and its instances, used to distinguish one type of object from other. Set of objects that share common methods and structured behavior. Okay, so say for example, you can see various objects in the institution, college management system. Okay, where you can group all the people, all the teachers, teaching staff. Okay, Rene Robin and other people. Okay, you can group them, and you can call them as teachers. And similarly, you can group or cluster other different type of people, non-teaching staff. Okay, so when you group them, they share some common functionalities that you must keep it in your mind. Okay, so what a common functionality? My responsibility is also teaching, and another teaching faculty responsibility also teaching, researching. Okay, so it cannot be shared with non-teaching faculty member. Okay, so this is how we can segregate or cluster the people, and you can cluster different classes in the particular problem domain. Okay, so first you need to identify the objects. When you identify the object, you have to identify its attributes, functions. I'll tell you the steps involved in identifying, formal steps involved in identifying those things. And once the objects are identified, you have to group them. While grouping, you have to identify the similar functionalities and call them as class. This is what the relationship between the class and objects. Okay, so the concepts of object and classes are intrinsically linked with each other and form the foundation of objects-oriented program. Class represents a collection of objects having same characteristics, properties that exhibit common behavior. Okay, this is the formal definition for a class. A class represents a collection of objects having, here I can give a teacher as a class. Object, Rene Robin is an object, can be considered as an object having some characteristics, properties that exhibit common behavior. Okay, the object-oriented methodologies, many methodologies have been, as I mentioned earlier, many methodologies have been proposed by various people, suggested by various people. But among them, the Booch, Ramba, and Jacobson method have been considered for the development. Okay, so what it is? A method usually includes notation, process, and tools. What notation? Graphical representation of classes and their relationship with interactions. I mentioned about internationally accepted. Okay, so we are sitting in Chennai at one corner, and some people will miss it. So since it is uniformly internationally accepted, we are using the same notation. Otherwise, some other may use some notation, some people may use another notation, other people may not understand what does it mean. Okay, so in order to avoid this mess and chaos, the universally accepted notations came to the picture in the form of unified approach by the great researchers Ramba, Booch, and Jacobson. Okay, don't forget. Okay, the contributors for the entire contributors. We are going to study their contribution as part of this, as the entire study. throughout our study, we are going to see their contribution alone, understand, okay? So when you study this object-oriented analysis and design subject, don't forget about the contributors, okay, who have contributed. It is not something studying and writing examination. You have to take something. Your takeaway must be those things. And process suggested a set of steps to carry out for transforming requirement into a system, working system, okay? So working system, the purpose of being here, my job is to teach, okay? That is what I am converting it into the working system. And tool software for drawing, here the pyramid clearly shows notations, process, and tools, okay? This is all about the object oriented representation. UML modeling language focuses on the output of the Booch, Rumba, and Jacobson is the UML focuses on standard modeling language and not a standard process. UML focuses on the concept of Booch, Rumba, and Jacobson. UML is a standard geographical design for object-oriented graphical design and a medium of presenting important analysis and design concepts. Here, I have listed out various diagrams of UML: use case diagrams, class diagram, package diagram, interaction diagram. We have two different types of interaction diagram: sequence diagram and collaboration diagram, activity diagram, state transition diagram, and deployment diagram. So let's see what is the use case diagram. A use case diagram, as its simplest, is a representation of users' interaction with the system that shows the relationship between the users and the different use cases in which the user is involved. Okay, so what you should know with respect to the use case diagram is, even a common man, when he look at the use case diagram, will be knowing about the various people involved or the various system involved in the particular system and its processes. We call those processes as use cases, and the people and the system interacting with the processes, we call them as actors. Then bank, then ATM, withdraw, we have different processes: withdraw cash and transfer funds, deposit funds, okay, we have here. So the three people associated with the system are bank customers and the maintenance person and the bank. Bank is a system, okay? It is not a human being, it's a system, okay? So bank customer will go to bank for what? To withdraw cash, to transfer fund, to deposit funds, okay? And the maintenance people are responsible for refilling the missions, okay? This is a basic diagram, simple diagram, an example for use case diagram. Here, actor, let us see what is an actor. An actor instance is someone or something outside the system that interacts with the system. It may be a person or it may be a system. An actor is anything that exchanges data with system. An actor can be a user, external hardware, or another system. Okay, it may be a database, it may be an ATM system, it may be a printer. Okay, so these are all some of the examples of actor. The notation recommended for an actor is this one. Okay. How to find actors? The next responsibility. Okay, once the problem domains are identified, it has been disseminated to, it has been given to the analyst. The actors supply, use, or remove information, use the functionality, will be interested in any requirement, will support or maintain the system's external resources. The other systems will need to interact with this one. These are all the ways who are, if you find the answer for these things, you will be getting the actors. And the documenting actor characteristics. So how will you document? What type of documentation is required? Documentation is highly encouraged in the software development environment. Whatever you do, you need to document it. What you are going to document with respect to actor? So what or who the actor represents? Okay, you find the answer and write it down. Why the actor is needed? Find the answer and write it down. What interest the actor has in the system? Find the answer and document. So it's all about the documentation of the actor. The actor characteristics might influence how the system is developed. the actor scope of responsibility, the physical environment in which the actor will be using, the number of users represented by the actor. We will see the standard notation for use case, a set of scenarios that describes an interaction between a user and a system, including uh, alternatives. Okay, so use case is nothing but the process, a set of scenarios that describes an interaction between a user and a system. This is what the notations used for the use case. So in the example, we have three different use cases. Transfer money is a process. Okay, so it is considered as a now withdraw money is a process, check balance is a process, and clients. These three processes are dealt by the actor. Okay. So how to find the use cases? Okay. So now let me tell the ways to find the use cases. If you ask these questions repeatedly, you will be getting the use cases. The first question would be, what are the system tasks for each actor you have identified? Does the actor need to be informed about a certain occurrences in the system? Will the actor need to inform the system about sudden external changes? Does the system apply the business with the correct behavior? Can all features be performed by the use cases you have identified? What use cases will support and maintain the system? What information must be modified or created in the system? These are all the questions. If you find the answer for the questions, you will be finding the use cases. Okay, different types of use cases, system start and stop, the basic use cases. Basic uses. If you want to operate a system, we need the to initiate the process, we need a login screen. Okay, that login screen can be considered as a use case. We need to write the option, we need to provide the option for entering the username, we need to provide the option for entering the password. Okay, it's a process. So it starts with and ending. Maintenance of the system, maintenance of data stored in the system, functionality needed to modify the behavior in the system. Different. So the terminologies are system boundary. You would have seen the system boundary in the previous slide. If you look at this, see, can you able to see this boundary? This is what the system boundary. Okay, so it's one of the components of the use case diagram. System and rectangle diagram represents the boundary between actors and the system. I always tell, if you refer some books, the actors will be placed wherever, some authors will use wherever they want to keep. But the standard procedure for keeping the actors, either you can keep the actors at the left side of the system boundary or the right side of the system boundary. Okay, so it looks very neat and nice. Use case diagram, the association, we have communication between an actor and use case represented by a solid line. Okay, this is what the association, communication between actor and use cases. Once the relationship identified, we need to establish a relationship. That relationship is represented with the help of this line. Generalization relationship between one general use case to the specialist. This the parent-child relationship. We are very familiar with the parent-child relationship. So it is called the generalization relationship between one general use case and the special use cases used for defining special alternatives, represented by line with a triangle arrow head toward the point parent use cases. Okay, so this pointer will point the parent use case, and this send towards the child use case. Okay, so generalization, when the word generalization, when I say it does specialization. So more generalized one is the parent use case, and the more specialized one is the child use case. Okay, so whenever we see this kind of relationship, we can go for this notation. So include so the properties or the things of one use case can be used for the other use case. Instead of mentioning everything in that what you can do is you can use this relationship. It indicates that it includes all the properties, all the functions of the particular use cases. And the extend is you are extending the extending from the parent to the child. Okay, you are extending one use case from the other use case. So it's a dotted line labeled this symbol, beginning at base use case and ending with the arrow pointing towards the include use case. The include relationship occurs when a chunk of behavior is similar across more than one use cases. We can go for this include instead of copying the description of that behavior. You're not copying it here. By simply giving the representation, it is understood that it's all those things are included in the particular use cases. Similarly, a dotted line labeled with an arrow towards the base case. The extending use case may add behavior to the base use case. The base use case declared extension points. You are extending from that. So here is a simple example of library management system, use case of library management system. A generalized description of how a system will be used provides an overview of intended functionality of the system. Here, as I said, no system boundaries here. We have identified 3 different actors. Name of the actor is client, the employee, and supervisors. So all the actors are human being. Okay, there is no other things. If you want, you can use. If you extend this use case diagram, you will be identifying some other use cases as database, printers, and something like that. Okay, so and this boundary, this actor, and this use cases. Okay, the association, we have association between the actor and borrow is a use case, it's a process who are relating. So client is requesting and the employee will be issuing. Similarly, order title, why there is no association between this use case and the client? This is purely dealing with the order title. Okay, only the people, those who are in the library will deal this issue. So the association we have between order title and the employee, order title and supervisor. Similarly, you have to identify the associations. Let us see the use case diagram of another example, clinical example. Okay, what is happening at in an hospital, where we can see the other associations like include and extend. Similarly, we have the system boundary, we have the various actors, patient, scheduler, doctor, clerk. Okay, so we have association between the patient and the cancel appointment, make appointment. The patient can make an appointment. Okay, and here the include properties are there. While making the appointment, check what the process. Once an appointment is while during the appointment, it will check payment patient record already been recorded in the hospital, so need not to have those functions here. Okay, here I'm including, so that is linked with the help of this association. And I will give an example for the extend here. This is the generalized one. There's a parent pay bill, and when you defer bill, it is extension. Okay, it is extension of this payment. Okay, so this is how we can. And generalization association, you have to use this notation. Okay, bill assurance, and this is the parent one, this is a child one. Okay, so while paying the bill, we have to consider the bill insurance. So this was the explanation for the previous diagram. Pay bill is a present use case, and bill insurance is a child. This is the parent, this is the child. Okay. Now let us see the next generation POS system. It's a case study. Next generation POS system is a common system we normally see when we go visit a supermarket. Okay, it's a computerized application used to record sales and handle payment, typically used in a real store. We have various components. The computer and barcode are the basic requirement, and the software. The interface to various service applications such as third party, we have to link with the tax collector and inventory control. Okay, they are all directly dealing with the next generation POS system and must be relatively fault tolerance. Okay, something happens, the system must be tolerated, and without compromising the quality of it, it has to update the information also. We need to provide some kind of mechanism for fault tolerance. So increasingly support multiple and varied client-side terminals and interfaces, thin client web server terminals. So it may be a regular personal computers, it may be a touch. Some shops will use only thin client web browsers. Some shops may use regular personal computers. Okay, the software which we are going to develop must support to all types interfaces. Okay, so the sold to different clients. Okay, this particular product has been developed for various people. Even the people in the medical shops will use, people in the supermarket will use, people in the big malls will use the same software. Okay, it is developed. The scope of the project is to develop the next POS, and the primary actor here is the cashier, one who is always sitting in front of the next generation POS system. Basically, the stakeholders are the cashiers, salesperson, customers, and company, manager, government tax agencies, payment authorization service. We will see different stakeholders and their interest. As far as this cashier concerned, he wants accurate and fast entry and no payment errors, as cash drawers shortage or detected from his or her salary. Okay, if the amount is not tally, immediately the owner will detect it from the salary of the cashier. So he is very particular about his interest towards this next generation POS system application. What is the interest of salesperson? Wants sales commission debited. Whenever you visit a supermarket, you will experience that after getting a product, the salesperson will put a tag with his number. It says that this product was sold by this person, and the respective commission will be added to his salary. Okay, this is what is expectation. Okay, so there should not be any flaw in the system of getting my commission. This is what the expectation, the interest of the salesperson. And what is a customer? As a common man, I am going and getting my product, and what is my expectation? Want to purchase and fast service. Okay, so we normally don't wait for the service. Okay, we always want fast service. Want the easily visible display of entered items and prices. I want to see the items. Okay, when I give my product, I may give a basket full of products. While putting the billing, I am interested to know my items and its relevant prices. Okay, wants proof of purchase to support returns. Okay, finally, I want to approve. It may help for various purpose. Suppose when I come back to return some product, I'll bring the bill. Okay, it's a proof. These are all the common expectation of the customer. And what is the expectation of a company? Wants to accurately record transaction and satisfy customer. Customer satisfaction is the major interest of a company, and record the correct transaction. Okay, want to ensure that payment authorization, service payment receivable as recorded. Sometimes when you use credit card or debit card, the payment will be paid by the payment authorization service. Some third party, some bank will provide. Okay, so that must be done very smoothly, and want some fault tolerance to allow sales capture even if server components are unavailable. Okay, so suppose some failure has occurred in the server, we cannot shut down the shop, or we cannot ask the customer to go and come back. We need to have a mechanism to tolerate this fault. Once automatic and fast update of accounting and inventory. And what is the interest of a manager? Wants to be able to perform override operations and easily debug a cashier. Something happened at the cashier side, immediately calls the manager, and the manager will come and rectify it. What is the interest of the government tax agencies? The VAT, the GST, they want whatever you sell, whatever you buy, I want GST to run my government. Okay, this is what the expectation of the government tax agency want to collect a tax from every sales, maybe multiple agencies such as national, state. Here, the 50% of tax will go to state government, 50% of tax will go to central government. They are dividing our money. Okay, so it is their interest. Okay, and payment authorization service like banks wants to receive digital authorization request in the correct format, and protocol wants to accurately account for their payable to the store. So these are all the expectations of, okay. So as a developer, when you develop an application for this particular requirement in the name of next generation POS system, you have to consider the interest and the requirement of all these stakeholders. Okay, when you look this application, it might looks very meager. Okay, but if you look at the functionalities, various functionalities, and interest of the various stakeholders, okay, you will be knowing the responsibility of you as a software developer. Okay, that is what our objective. Why I am telling this next generation POS system, you and me, what is happening we know, but this is what is happening inside a software. As a software developer, you have to satisfy the request of all the stakeholders. Precondition cashier is identified and authenticated. Okay, not all the people working in the shop will be allowed to operate. Okay, only the identified people, and authentication is provided in the form of username and password or the biometric applications. And the success guarantee is post conduction. Once the transactions are over, we have to ensure the sale is saved, tax is correctly calculated, accounting and inventory are updated, then commissions are recorded, receipt commissions to the salespersons are recorded, receipt is generated and given to the customer, and a copy is preserved for this shop, and payment authorization approvals are recorded. These are all the success guarantee after the transaction got over. So here the functionalities, what is happening at, let us see. Okay, main scenario, what is happening. Customer arrives at POS checkpoint with goods, with a basket full of goods. We are approaching the customer, and cashier starts the new sale, taking out of one by one from the basket, and with the help of the barcoder, the cashier enters the item with the help of the barcoder, and it will be the system record the sale immediately. Once the barcode identified the bar, it will be displayed on the screen along with the description, price, and running total and price calculated for a set of the system records line item, presents, description, price, okay, everything. Then repeatedly this happens. Say for example, if I bought 10 to 15 items, the 15 times the same things will be repeated, and system presents total with the tax calculated. Then cashier tells the customer this is what the total you are supposed to pay, and the customer may give money or can give some credit card or debit card. A system logs completed sales and sends sales and payment information to the external accounting system, so that the people, those who are taking care of the inventory, will take, and the inventory people, it will take care of the necessary steps to update the inventory, and the system presents a receipt, and the customer leaves with a good with receipt and goods happily. Okay, these are all the various steps involved in the flow. Okay, so this is what story we have heard so far is the requirement. Okay, you are the developer, assume that you are the developer, I am the customer, I have approached you and informed everything. Now it is your job to develop object-oriented system. You have to apply the object-oriented analysis concept, object-oriented design concepts. Okay, so case study, the helping factors are the unified approach and the layered approach. Okay, don't forget about it. We are going to use the unified approach and the unified approach and layered architecture. So here the application generally can be divided into 3 types as per the recommendation of the layered architecture. 3 phases, layers are there. One is user interface, application logic, other components. Focuses on application logic layer because we are our main focus is application layer. So this is what the architecture. Okay. So architecture layered architecture starts with the user interface. Okay, this is the small thing. Minor focus explain how to contact. With the help of this user interface, the authorized cashier will enter into the system. Okay, so the main focus is on application layer where we deal with all sales and payment. Primary focus of the case studies explore how to design objects, and the third one is the other layers, logging and data access or others. Okay, our main focus is on the second one, that is application layer. Okay, so these are all the various actors identified. Here we have identified various actors: cashier, and another actor, sales activity system, system administrator, store manager, then payment authorization service, tax collector, accounting system, human resources system, inventory system. Okay, so this were the use cases and the relationship. These are the relationship. Okay, don't be confused with the representation, two representation for actors. So as I said, no, the actor can be maybe a human being or the system. Okay, when if you want to differentiate, you can use this notation for the non-human being actors. For the human being actors, you can use, or you can use the same human being notation for all actors. No, nothing wrong with that. Okay, next generation POS system. Inception, we have use case model describes the proposed functionality of the new system, represents a discrete unit of interaction between user and the system, a use case in a single unit of meaningful work. Here we deal with the login system, register with the system, and creating order. Okay, here each use case has a description. We can use the use cases, we can include with extension. Use cases are typically related to actors. An actor is a human or missions, all we have studied earlier. So these are all the questions for identifying actors, and I think we have seen all those things, identifying the actors. With the help of these questions, we can identify the actors. Inception phase. Okay, so we'll identifying the actors, but we will identify only 10 to 20% at this stage. 10 to 20% of use cases that represents a core complex functions or risky ones are re-returned and fully dressed format. So fully dressed format is nothing but the objects with all properties and the functions are fully dressed format. Okay, this diagram is clearly telling us the completion level. Inception phase, 10 to 20% of the use cases will be identified. What is happening at elaboration phase? In elaboration phase, it is very risky and high value and architecturally significant parts of the system and incrementally built. Okay, so the majority of the requirement are identified and clarified at this stage. At the elaboration stage, use cases are prioritized and each iteration focuses on a subset of the most important ones. And here the team's understanding of the requirement increases after each iteration through feedback from various iterations. Requirements are iteratively and adaptively refined and becomes stable gradually. Here we will be identifying or finalizing almost all the use cases. 80% to 90% of the use cases will be identified here. The construction, now we will move on to the construction phase. Where some of the remaining use cases will be identified when the work on progress. So construction phase focus on completing the systems. Once the risky and core unstable issues have been settled down in elaboration, we move to the construction phase, and there will be some minor use cases. As I mentioned earlier, they tend to 15% of the use cases left in previous phases will be identified here, and the majority of the core functions and non-functional requirements have been iteratively and adaptively stabilized here. Okay, this is what the use case diagram for the next generation, the problem domain which we have discussed. Okay, here the various actors are there. System boundary, this is what the system boundary. And the actors, we have identified various actors, customer, cashier, manager, then sales activity system, payment authorization service, tax calculator, accounting system, HR systems, okay, and various use cases associated with this particular next generation POS systems are process sales, handle returns, cash in authorized activity, manage security, manage users. Okay, so now we can able to see how these associations are established. Here, customers and process, customers directly dealing with the process, and the payment authorization system is dealing with process sales. Okay,